Hi everyone, welcome back. Unfortunately, I can't be there with you this week. I've broken my leg, broken my ankle. Hopefully, I'll be there next week. But I'm going to in a wheelchair, or I got crutches and things. Things aren't going well. All right, just want to give you a quick run through of a couple of slides that I would have presented in class, help you out a little bit for today. So we're starting off our new topic of integration. This is a part of calculus, and we're going to start by looking at finding the area, using the area under curves and things to interpret integrals and solve problems. So our first look is at velocity time graphs. So if you remember from science and IM3, in a velocity we have the relationship that velocity is equal to distance over time. Physicists use s for distance. So that means that distance, s, is equal to velocity times time. So if we're looking at the graph here, we've got a graph of a velocity time graph, and we want to interpret the graph and find out how far it has traveled. So we have to break the graph down into different segments. Look for different polynomial shapes to help you with this. So we've got this first section where it's traveling a constant velocity of 8 kilometers for the first 4 hours. So that's fairly easy. The velocity is going to be 8 and the time is going to be 4. That's going to give us 32. The units are kilometers. But 4 times 8 is this how we would calculate the area of a rectangle, which is 8 high and 4 wide. So if we look at the shape here, we'll go chubby fingers. Look at the shape here. This is 8 high and 4 wide. So we're basically calculating this area here. So if we're calculating that area there like that, if we're calculating that area there like that, then the area of this triangle is also going to give us the distance it travels in that period. So we've got a triangle there which is 8 high again, and it has a base of 2. So the area of a triangle is going to be, let me switch to my pen. The area of that triangle, the second distance, is going to be a half times 8 times 2, which is going to be 8 kilometers. So the total distance is going to be 40 kilometers. And that's how we calculate the distance traveled, or the displacement. Okay, so we've got a velocity time graph here, and we need to find the distance traveled. So what we need to do is we need to find the shape of this triangle. In order to do that, we need to find the height to here. We need to find the length of the base. So let's just use our calculator for that one. We'll have a new calculator. I'm going to add a graph, Control, add graph, and I can put that in. That is minus -5 times x plus 10. We get a graph looks like this. I need to extend this up. It's going to go up a little higher. Let me just change that, and we see the graph. We want to find this intersection here. That occurs when the time is equal to 0. So we'll get the calculator to calculate that one for us. There's a couple of ways of doing it. We can press menu, trace graph. How far is it after 0? Press enter twice, and we can see it's there at 10. We want to find this intersection, so we want to find when the function has become 0, and it'll give us the intersection there, and we'll get the length of the base. You can see that it's 2 there on the graph. But one way to calculate it with the calculator would be to analyze the graph, find the zeros. We've got a 0 that occurs in between 2 here, and we see that it occurs at 2. So what we know now is that this is at 10, this is at 2, so the distance is going to be the area of this triangle, half times height times base, which is going to be 10. And the units are in meters. We can see up there the velocity is in meters per second, so that's going to be 10 meters. A little bit more tricks for your calculator, a little bit of reminders. So we can see the shape of this. We've got the function entered. We can press the variable button here and find out what the function value is when t equals 0. And we want to find the root. So to find that one, we would use our beloved friend nsolve. And we want to nsolve when the function, in terms of x, is equal to 0 and solve for x. And we get 2. So 0.5 times 10 times 2, 10 meters. Okay, to find the area of this graph, we need to find the lengths of these shapes. So we can see it goes through the origin here at this point, and you can understand fairly easily if you put 0 as your x value into there, you're going to get 0. So it's going to go through 0, 0 there. We need to find this point. So in order to find this point, we're not given the x value that occurs, so we have to find a first. So we can do that using our graphing calculator. If I go in and adjust this now, take away that previous function, I want to draw the two functions. I've got 1.5x as my first one, and then my second one is y equals 3. So it sketches out the shape for us a little bit here. And what we're after is we're after the point where these two cross. That's the interesting point for us. It's going to give us all the information we need. So if we analyze the graph on this one, we need to find the intersection. It's going to occur here. So this point here is at 2, 3. So our distance is going to be the area of the triangle, which is a half times the length of that base, so that's going to be 2, times the height, which is going to be 3, plus the area of the rectangle, which is going to have a height of 3 and a base. So if this is 2, that's 5. So 5 minus 2 is 3. So that's 3 by 3. That's going to give us 12. Any units? No. Distance units. So we got 9 plus 3, 10, 11, 12. Yeah. Other techniques on the calculator for that one. Got the two graphs drawn. I want to nsolve. Let me just widen that a little bit. I want to nsolve when function 1, defined on the variable x, is equal to function 2, defined on the variable x, and we're solving for x. That would give us the 2. Okay, is that it? Yes, I'll leave you to the investigations for yourself. Good luck, everybody, and I hope to see you all next week.